Hi guys, in this video we'll take a look at another problem whose difficulty level is easy. So in this problem what we have to do is we have to implement square root method which takes in an integer and then returns as integer. So the return value is square root of that number. There are a couple of assumptions that we can take. So first one is x is non-negative integer, so our input is non-negative. And the second one is since our return type is integer, we can ignore the decimal part of it. So let's look at our examples. So if we are given 8, then we need to return 2. We know that square root of 9 is 3, so square root of 8 would be 2 point something something. So we ignore the decimal part, we return 2. Likewise, 120, we know square root of 121 is 11, so 120 would be 10 point something something, so we return 10. And for 122, we return 11. So that's our problem. You guys know the drill. Let's go to the whiteboard, figure out the approach, and then come back and run the code.
So let's figure out how we can find out square root of a given number. So we know that square root of 8 is 2 and square root of 120 is 10. So there's a fun fact or a relationship between odd numbers and perfect squares. If you guys don't know, then pay attention over here. So 1 plus 3 odd numbers always equal to perfect square. So 1 plus 3 is 4, 1 plus 3 plus 5, which is 9, which is again a perfect square. 1 plus 3 plus 5 plus 7, 16, again a perfect square. And you guys can keep on going. I assure you, it'll give you perfect square. So we can use this property to calculate our square root. So what we'll do, 1 plus 3 is 4. So we are using two odd numbers, right? 1 plus 3 plus 5 is 9. We are using three odd numbers. I mean 3 digits of odd number or 3 odd numbers, whatever. 1 plus 3 plus 5 plus 7, we are using 4 odd numbers, so 4. So we can use this property to find out square root. So what we say 8, we say okay, 1 plus 3 is 4. Yeah, we can use two odd numbers. 1 plus 3 plus 5, which is 9, which goes greater than 8, so we can't use three odd numbers. So we have to restrain to two odd numbers, and that's our square root. Likewise, 120, we can do keep on going till we have like 10 odd numbers, and then moment we use 11th odd number, which is 21. Our sum is 121, which is greater than 120, so we say that our square root is 10. So that's definitely a way to implement it. That's easy way. The time complexity for this approach would be O of n, since we are linearly incrementing our numbers till we reach our number, and then we say that we use 10 digits or 20 digits of odd number, and that's our square root. So that's O of n. So that's a good approach, viable solution. However, we want an approach which is even quicker than that. So let's look at how we can do that. Okay, so what we'll do in this approach is we'll try to implement kind of binary search to find square root. So let's look at this example, square root of 120. So what we do is we make our solution set as 1 to 120 range. So 1 dot 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 dot, let's say midpoint is 60 dot 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 120. So this is our solution set, right? Possible solution set. So we start at midpoint 60. So we said, okay, is this our square root? So what we do, 60 into 60, which is 3600, which is more than 120. So we say that, okay, this definitely is not our solution set, and our solution set somewhere lies on the left, right? So we take next midpoint 30, right? And now we do 30 into 30, which is like again more than 120. So we say that, okay, our solution set is not on the right, it's still on the left of 30. And we keep doing that until we find our solution or square root of that number. So this is our code of doing binary search, the approach that we just discussed. So what we do, we take left is equal to 1, we take right is equal to x, and then we loop till left is less than r. So what we do, we figure out midpoint, left plus r divided by 2. And so instead of doing like multiplying 60 into 60, 30 into 20, what we do is we do division. So there is a possibility of overflow, like we multiply two big numbers, large integers, and then it'll go out of integer, 32-bit integer value. So what we do is we divide. So same thing, it just instead of multiplication we divide. So we divide x, so 120 divided by mid, which is 60 or 30, whichever, and then we compare which direction we need to go, whether we need to go in right or left, or whether we found the answer. So let's run this code and let's look at the values that we get. So our left is 1, right is 120, right? So our mid would be 60. Now we divide 120 by 60, we get 2. So this is definitely less than mid, right? So we say that, okay, our solution set exists on the left of 60. So what we do, we say, okay, right is now 60. So our possible solution set is 1 to 60. So mid is 30. Now 120 divided by 30 is 4. So which is still less than mid. So our solution set is still on the left. So our solution set is between 1 and 30. So we get mid as 15. We say, okay, our solution set is still between 1 and 15. Now we get mid as 8, and 120 divided by 8 is 15. So this is greater than mid. So now we need to move left to the right side of it. So we say our solution set is now between 9 and 15. And we keep doing that until we get left is equal to right eventually. And we'll come out of this loop and we'll say return left minus 1. So we'll say 11 minus 1, which is 10, is our return value. So that's square root of 120. Now, since we are using binary search or binary splitting kind of algorithm, so our time complexity would be O of log n, and that's better than the previous approach. So there you go, guys. This is the approach that we can use to implement square root. So now let's go to the computer, let's run the code and make sure that we get our required square root.
Okay guys, this is our final code for finding out square root of an integer number. We are doing the binary implementation of the problem. We have left as 1, right as x, and then we keep dividing them into two halves, and then we keep throwing the half which we don't want and keep picking the solution set of that half. So let's run this code, make sure that we get our required square roots, and confirm that. So square root of 120 is 10, square root of 122 is 11, as expected. So there you go, guys. We do have C# version, we do have Java version. Both of them would be linked in the description. So if you guys like the video, if you guys like the approach, if you guys learned new thing, then click that thumbs up button and let me know your feedback, suggestion in the comments below, and then subscribe to the channel for more videos and keep on doing more algorithm and data structure problems.